Hey everyone, let's start with question number 4, Digital Electronics, asked in GATE Examination 2025. A 10-bit analog to digital converter has a sampling frequency of 1 MHz and a full-scale voltage of 3.3 volt. For an input sinusoidal signal with frequency 500 kHz, the maximum SNR in dB rounded off up to 2 decimal places and the data rate in Mbps at the output of the ADC are respectively. Before going to the question solution, there are some prerequisite formula you should be aware of. So the first one is SNR in dB, which is equals to 6.02 n plus 1.76, where n is equals to number of bits, and the second important formula is data rate, which is equals to sampling frequency also known as sampling rate, or you can say sampling rate multiplied by number of bits per sample. Now if we look at this SNR in dB, we will use that the generalized form. So what is SNR, which is nothing but signal power to the noise power. I am just showing where this formula came from. In order to handle other types of question, you should be aware of the basics of this SNR. So signal power is V full scale voltage square divided by 8 plus noise power is del square upon 12, where del is nothing but the step size, which is full scale voltage divided by 2 to the power n, where n is again your number of bits. So noise power comes out to be full scale voltage square 12 2 to the power 2n. Now SNR would be V full scale voltage square divided by 8 whole divided by V full scale voltage whole square divided by 12 into 2 to n. The full scale voltage gets cancelled out. It comes out to be 8. It comes out to be 12 upon 8 2 to the power 2n. This gets cancelled out further for 3, 2. So SNR in dB, which is equals to 3 by 2, 2 to n, we have to take 10 log, which comes out to be your 1.76 plus 6.02 n. Here this formula came. So in this question, it is also written a full scale voltage of 3.3 volt, but while finding the maximum SNR, you won't need this value, because you already see that full scale voltage gets cancelled out. So whenever it is asked signal power separately or noise power, then you need the full scale voltage. Otherwise, in calculating the SNR, you are not using the full scale voltage. So on putting the value of n is equals to 10, the answer comes out to be 61.96. Now the second part is sampling rate is also given is 1 megahertz. You can read this sampling rate as, it says 1 million samples per second. So it is written that it has sampling frequency of 1 megahertz and a 10-bit analog to digital converter. So if you see the data rate formula, it says the sampling rate in the number of bits per sample. So sampling rate is this. So data rate would be 1 million, I am writing this unit into per second just for clarity, into 10 bits. So it would be 10 megabits per second. So your answer will be option A, 61.96 SNR and 10 megabits per second your data rate. I hope you understand the basics of this question. This question doesn't have much procedure. You should know only aware of these two formulas, but for the sake of clarity, you should know the fundamentals of this question. Thank you.